¿Qué tal, mis estimados amigos? El día de hoy vamos a realizar un análisis con el software SASS-C. Como podrán ver en esta primera pantalla, lo que primero que tenemos que hacer es realizar una grabación de la salida de los datos de nuestro radar. Lo podemos realizar en categoría 1, 2 o categoría 34 y 48. Y bueno, lo primero que tenemos que hacer es realizar una captura que sea más o menos alrededor, lo mínimo, podría ser de unas 12 horas para tener un buen análisis. Pero pues si tenemos el día completo, esto es mejor. Como pueden ver en esta parte, después de que se hace la captura, lo que tenemos que hacer es exportar nuestra grabación a RAW Asterix y posteriormente guardarlo con la extensión .raw. Bueno, lo siguiente que se tiene que hacer para realizar el análisis del software, una vez que ya se hizo la captura de los datos y ya se guardó en RAW, es pasarlo a nuestra máquina virtual. Si se fijan aquí yo ya la abrí, así es como inicia. Es una máquina virtual, es un CentOS 5.4 si mal no recuerdo, como lo podrán ver aquí. Eh, eh, y esta máquina virtual la tenemos que correr en este Oracle VirtualBox. Lo siguiente que tenemos que hacer pues es pasar nuestra grabación. Más que aquí hay que tener mucho cuidado. Bueno, antes que eso, el usuario es SASS-C y la contraseña también es SASS-C, así como se escucha. Una vez que entramos aquí, lo que tenemos que hacer es dejar nuestra grabación en SASS-C Home. Si se fijan, nosotros aquí tenemos una carpeta que dice rec y lo correcto es dejarla en este lado. Si se fijan, aquí yo ya puse una de Peñón, tengo una de Querétaro y por ahí creo que tenía una de Guadalajara también. Entonces, no se les olvide, esta es la de Guadalajara. No se les olvide que debe de ir aquí en esta carpeta, porque anteriormente yo estaba cometiendo el error de dejarlo en el escritorio, pero la aplicación del SASS-C no tiene acceso a nada que dejemos aquí en el escritorio, entonces nunca lo va a abrir. ¿Sí? Entonces hay que tener mucho cuidado con eso. Okay, we have to create a new task. This is Mexico. The name of the country, right?
You can do it like this because you did all of the
Yes. Okay. Well, I will create, but I will delete this one. Okay.
So in this one you can create, you have to create the data box, and you will create the radar of the radar.
Okay.
The coordinates and so on.
Show data banks, radar data bank.
Right click. Yeah. Create object.
Create object, radar. This is GDL. Okay. Sí.
So you put the coordinates identifier to your coordinates.
The identifier has
be
four, right? GDL1. Lo voy a poner de tales, ¿no? Letters, or it could be numbers?
No, it cannot be numbers,
Okay.
only letters.
KDLT. Okay. Latitude.
49.
Yeah.
20, 31.
Tenemos que poner las coordenadas aquí. Es 20. ¿Mande? No sé si son las mismas. Sí, las mismas. 20, 31, 58.8, North, 103,
18,
19.
18,
Ah, sí.
35.9.
20, 31, 58, 103, 18. West. Revolution time 4. Yeah. Ground altitude. $1,550 metros. Radar type is primary modes. Okay. Antenna type single. Usage civil approach or civil?
You make an approach.
Yes, civil approach.
It doesn't matter after it. It doesn't make any change in the analysis.
Okay.
Just the characteristics of the radar.
Civil approach.
Streaming file, I'm not sure they will be available here in North America. This is to see all the obstacles around the radar and to take it into account in the calculation of the. We will check, but I'm not sure it's available here. It's
Like,
mainly in Europe that we have it.
For the parentheses, I have the Java visibility curves creator of you.
But we cannot import it.
Okay, that was the question. Okay.
What is possible to do is on SASS-C 8 they have all the maps for all the world.
Okay.
So we can generate the curve in phase CV8 and to import it in phase CV6.
Okay.
But from this tool, the Java tools we have, visibility curve, we cannot set.
Okay.
But after, it's not a big issue.
Okay.
To have the screen file. I will just check it here.
We have to compute here.
Yes.
256.
56.
Okay.
After we have to change
This
with all the things.
DTD only?
DTD only.
Okay.
But I'm not sure we have it. No. DTD only we don't have, and if we have in the DCW. No. So we will not have it for this part of the guide.
Okay. So I only close this one?
Yes, you close. We will not choose it.
And FAT, okay, the range is stayed 256.
Yeah.
Okay.
Modest system map, this is to import the coverage map, but here I think you have a full coverage. The coverage map is until the end of the secondary radar range.
I'm not sure.
What is the tolerance of the presentation of the glucose taken into account this
In fact,
it seems at first glance that it's moving, but that is not true.
Yes, this is true. It's moving a little bit because it depends where you receive your reply in the log. So this is normal. Yes. But
This normal, but if I translate this in meters or decimals or miles, it's too much for me, because in the information you say that the equipment has a precision of 25 meters.
This is 0.068
degrees, but in distance, can you measure that in this case,
But in fact, we have to do it like this.
more than 100 meters? ¿Te acuerdas que yo te lo mandé a ver?
So it's this extension. So 676. We are better than 0068 degrees. No?
It's almost, if I only put the difference, and this is
38, 35, 0.003 degrees.
can you see? Almost the equivalent. Okay, in this case it's better than before, because
I just send the coverage map to the ID to see what is the maximum size. It's 200. It's a cylinder of 200 nautical miles. The coverage map.
Ok.
So it's a full circle.
Yes.
So here we no need to put a specific surveillance map.
Okay.
We make the analysis until the end of range. In some specific countries, we have some cutouts on the coverage
Okay.
map. That's why we put it here. So that's fine. And here we have to make the characteristics. So maximum range for primary
60.
60.
Yes, it's 60.
Electrical height. So normally this value, the ground altitude,
Close the tower.
1550. So this is the ground altitude, and here you have to height the electrical height. So height of the tower. Primary antenna. Putain, comment je le dessine? PSA X plus. So it's 2.5 usually we take the center of the reflector.
Okay.
And the secondary radar one. I think it's 4.5, we take 2 meters higher.
4.5.
4.5, 2.5. So you know the height of the tower? It's
20.
Okay.
centimeters.
22.5. So this is for the primary electrical height 22.5.
Okay. And
And for the primary
24.
24.5.
$200.
Here, it's very important to put your SASS-C.
Yes. 251 and 17. The APPL, what is?
This is when you receive several data flow.
Okay.
So this you don't care, you can leave it to the default value.
0?
0, 0.
Okay.
What is really important is the SASS-C.
Okay.
And that should be fine. We can save it.
Okay.
Save and quit.
Okay.
So now you can create the next one, which will be your campaign. So we put the date, February 2025. You should call it Guadalajara.
It's okay. Right.
And now you display, so you right click on this one and you display the data banks. So we are in the data banks of this campaign, and here we are going to make all the settings for this campaign.
Okay.
Okay. So mainly what we have to do is data banks. So we have the radar recording details. You have to change it. So we put the date of the recording 04/02/2025.
04, 02.
Okay.
The recording start and the recording stop.
This is right here.
Okay.
We will read directly from our file.
Okay.
What you have to be careful is to change here message format asterisk, view modified convert option from this one.
Okay.
So you leave it at asterisk.
Okay.
And here there is something that you must change. Put track as plot. Because in your recording you have some tracks and SASS-C worked with plots.
Okay.
So that's fine.
As plot true.
Put track as plot is true, yes. You
Okay.
have to implement it. And file format, you will change it, you will add this line. Because by default it's configured to use the internal recorder of the SASS-C. And
Okay.
as you use an external file, here you say that the data in the file is pure asterisk data. So you can hide these two lines.
Okay.
Use time, the NTPS time from the recording, and file format is asterisk pure.
Use
underscore time equal space equal data. Space equal space data.
What is the equal?
Yes. Space data. And just below, file underscore format. Space equal space 80x underscore pure.
Okay.
And save it.
Save and quit.
Save and quit. input medium, it will be a disk file. Okay, so you leave it like this, and we will select the file at the end. No need to select it here. Here, you will have to set two radars. So the first one, we are so radar number 0, we are going to use Guadalajara, that we have created before. Okay. Here, the coordinates are not the correct one. If you click on set as, it copies the one from Guadalajara.
Okay.
And then we have to create a false radar, so you can leave this one merdam. It will not be recognized. Your line number, it will be on number 0. You have only one line in the file, and this is fine. You can save. Next thing we are going to do is program parameters bank. So you right click, you click on it, double click, double left click, voilà. And we want to adjust the characteristics for the chainer, for the correlator. So you can double click on the correlator. And here you have to put one more time the coordinates of Guadalajara. So here
it showed the Guadalajara ones.
you have already the Guadalajara?
Yes.
Okay. So you just copy this one to this part, to the area filter. Pourquoi je n'ai pas mis Guadalajara?
20, 31,
Okay. So this is fine, fine. Okay, you can confirm and save. You can open the Muratrek multi-radar trajectory reconstruction.
Okay.
And then in file, operator file, parameter estimation constant.
Parameter okay.
Here, your Guadalajara radar, you have to select it fixed in place and fixed in time.
Okay.
And the false one, you keep it fixed in place. Okay.
Only that.
Yes. Here, the recording is primary and secondary, so you will use the altitude.
Okay.
If you make an analysis of a recording with only primary, you will have to remove the use altitude.
Okay.
So here you can save and quit. And confirm. What else? Here it's not so bad. Yes, sorry. One more time in the Muratrek. You have to go in the radar measurement, I think, yes. You go in radar measurement. You go to the previous until, this is Guadalajara. So standard deviation from range is 15 meters.
Okay.
And azimuth accuracy 0.068. You can save. What you can check is for the false plot analysis. You must be sure that the false plot analysis will go until the end of your primates. So here you put the maximum range of your secondary radar.
200.
200. And that should be fine. And that's fine for this. It's okay, nothing else to consider. So once this is done, you can make the next step, create object configuration. And the recording I made was PSR channel A and modus channel 1. And it was in circular. Well, make this to...
Okay. Configuration. This could be the details of the recording.
Yes. Yeah.
PSR channel A. Mode S channel 1. Circular.
And next one, create object evaluation. And here the evaluation is based on that time GDL.
Okay. GDL. Okay.
So once this is done, you can check your recording detail. You can display this data bank. So you right click on your evaluation, data bank show. And in your recording detail, here you will link to your recorder.
Okay. Yeah, in the evaluation.
Yeah.
This one.
Yes, exactly.
Only okay?
Yeah. So the other is set, so that's fine, you can save. Then you can double click on it. And first thing you have to do is an analysis. So right click, analysis, radar statistics.
This one?
Yes.
Okay.
And batch start.
Batch.
Or run. So, and here is going to check the number of plots you have in your recordings.
Okay. Right now we are recording. Okay. After this, right now I have the recording, and then
one more time on the recording. Right click on the recording. Next process.
Object correlator.
No. Make this every time.
I don't know. It's strange. Okay, OC. One. Okay. Everything seems to be okay.
Fine.
Confirm.
That's fine.
That's run.
We will have 6 hours and 20 minutes of recording.
A lot of steps. and I'm not very familiarized with the software. I think once I practice more.
I will make it in 5 minutes.
Yes.
Non, parce que pour acquérir un logement vite fait, 97.
I got 97. It must be more than 90%, right?
Yes.
Okay. File, quit, next process. No, analysis.
Tabular PD, CD cell PD, and
Tabular PD, probability detection. I have to select here the
OC1 civil file.
OC1 civil file. Yes. File, confirm. Analysis, 3D, and the same OC civil file. Okay. File, confirm. Analysis, false plot. And here I don't have to. Yes. Okay. Batch, run. Okay. Right now we have the primary, the model AC probability of detection, and the primary model AC combination rate, and the roll call probability 98.79. If at first, well, with no filters applied, what is the I can take a good result for this one.
Yes, with no filters and so on, this is
okay. But without what is the value that I can consider that is wrong here with no filter? Just for
this is difficult to say, but if you see lower than 90%,
okay,
you will never be able to filter enough.
Okay. And after that, 3D, parameters, measurement type, roll call modes, okay, tabular presentation, polar presentation, vertical presentation.
There are some mountains as well.
Yes. Yes, Querétaro is very blind, yeah, as you can see. Okay, so these are the ones that we are going to print the screen, right? As it is, like that. Okay, file, quit, and after that,
right click, file view report.
File view.
Reports.
In reports.
And you have to go to
the 15. False plot generation rate. Multipad, azimuth. 001 or okay. This is the one that you take.
This is the one take to put in the report.
Okay.
Do you want an example of the report?
It will be helpful. Okay. Then after this,
After this, you have to make the neural track.
it's on the
Right click here, next process.
next process, neural track. Yeah. I don't know why this happened.
So you can go in the filter section, and you will add the SC1 civil 5
SC1 civil 5
and pass acceleration one click here. And the same for the bottom one.
SC1 civil 5 and pass acceleration quickly.
So you can set in the files, operator files, parameter estimation constants, this first one.
This one?
No, parameter estimation constants. So you use the altitude and the reference radar is 16 place and in time, so this is fine, you can click. Radar site information, radar measurement, 15, okay, that's fine. So everything is fine. You can make a file confirm. So you can slide on the right. Next process. Yes. File confirm. Next process, trajectory. On the end. 1 and 2. File confirm. And finally, plot accuracy. New. And do not use systematic error. And that's fine.
File confirm. And then
Batch value. And once it will be calculated, I will show you how to change the range.
Thank you. And wait. And this error. Answer. Okay. We finished. After this,
Double click on the accuracy. can use the value, view statistics. 0047 for the azimuth. Okay.
This is okay.
Nice.
And then range, view, statistics.
A little bit more than 15. So this one will need maybe a little bit of filtering. Checking the reconstruction, trajectory from the SASS-C and your track, and to see if there is some oscillation, something like that. That will show.
Okay.
But when you get so close from this value, it's easy to go below 15. To check, you can click on OK. View, tabular report. And you will select aircraft identifier. It will classify according to the track number. Okay. And then you click on SD and you sort SD. And one more time to see the worst value on top.
Okay.
So this one is 15 period. So you can check this track number 167 and check if there is some oscillation, and then you can remove it from the statistics.
Okay. So it's a 563.
That's the number of sample, the chain number you need to take. 167.
If I want to remove, like, from here to here,
you take all the track numbers, 167, 155, 168, and 412. We will remove this forward. So you quit this window.
cancel.
Yeah. Cancel. And you do a filter. Filter, create step, filter out, IDF. You create the filter.
Here?
Here, no, create.
Okay.
Create filter according to the chain number.
Okay.
And here you put the number 167.
167, comma. 155, comma.
168.
168,
And
comma.
412. And okay. And you can check one more time the statistics.
We are in range, statistics.
But normally before we filter, we check that we really have some oscillations and so on. But to have such a value, we will find some oscillations.
Okay.
If you want to change the display here, you can right click in the window and set scale. Sorry. Cancel. This we will make after. Right click, set scale, set bucket size. And instead of 100, you make 1.
1?
1, yes. This is the slice of the drawing, in fact. So, okay. And now you can set the scale to -75 to +75, for example. Here, yes.
No, 75.
75.
It's okay?
Okay.
Okay.
So you can enlarge after, you start at 35 or according to what display you want to do.
Yes.
But you see the Gaussian like this. It should be a Gaussian, in fact.
Okay.
And the same for the azimuth, it's the same principle. You change the bucket size. 0.01, for example. I would have another 0.001. But it's the same principle as for the rest.
More, no?
And after you change the scale to be between minus 0.15 and plus 0.15, for example.
Minus
0.15 and plus 0.15.
error. Okay. For what is this one?
This is the density range versus flight level. So it's according to the altitude of the aircraft, and you see some statistics according to the altitude elevation of the aircraft, in fact, regarding the radar.
Okay.
We don't use so much this one. What is interesting sometimes is azimuth scatters. For example, you can see in which azimuth you have some deviations. See? Here, for example, this aircraft is probably one that should be filtered. This is this track number, and you see it has a very, very wrong value, minus 1.2 degrees. So this is probably due to the oscillation that we show in the trajectory.
This is the same aircraft.
Yeah, same aircraft. Yes. That's why it has probably some oscillation in this aircraft.
And if I want to remove this one,
So you can do filter out, selection,
action filter, or
normally we can filter out directly the selection. Create with, sorry. Create with, filter out, and your selection. And this will remove all your black points from the statistics.
so I will be.
You can make the same in range. So you see there is one azimuth where you have a lot of range. But if you remove this one, these two ones, and some on the tops, maybe it will be okay.
This
And this one as well. Maybe you will be below the 15 because we are close here.
read width, filter out, selection, create, filter, view, statistics. Okay. Okay. So, and that's it.
It's as simple as that. Once you know all the small tricks,
Yes.
that's the problem of SASS-C. It's not very user-friendly.
Yes, not really. Great. Okay. Okay, and once I want to, for example, I close this, and I have the GDL and Querétaro right now. And if I want to only open it's only this, and I can consult. Okay. Okay, very thank you. Thank you.